This is a review video of chapters 2 through 4. I'm basically going to just make this program using everything that we've done thus far, but the best thing for you to do is just actually go back to the other videos and watch all those as well. But if you just want something quick and just to follow along, you can use this. And of course we'll have a question and answer session, the class before the exam. So here we go. So talking about variables, or actually just talk about the template, right? We first start out with a preprocessor, standard.io.h. We can have comments by having the double slants. We can do multiple line comments by using the open ending brackets that are the /*/ multi-line comment. And okay, so back to the template. We started out with the preprocessor, and then the int main. Int is the return type, main is the name of the function. Then you've got your parentheses open and close for your arguments for that function. Then we have the open and close brackets for the code block itself, and then we have the return statement and returning an int, particularly a 0 in this case. So we talked about variables, printf, and scanf. So variables, they can hold data for us. There are 4 different types: the char, double, and float. Float and double can hold fractions of numbers, so you can have 3.14159, 2.2, whatever, anything with those fractional numbers, while an int and char can hold only whole numbers or integers, where char can only hold 256 different values, both positive and negative. So that's like minus 128 to 128, something like that. And integers like 2.5 billion plus or minus. Okay, and then even bigger for the double. So with that being said, we define and declare variables. In this little example, we're going to make a little menu, and based off of what you select, it produces a sum, average, or product of the 5 values that it asks you to input. So the first thing I'd like to tackle is the actual prompting and storing of user input from the keyboard. So first off, I'd like to create a hard-coded variable called number of inputs, and I just made it capitalized just to show that you can use underscores. Variable name should always start with a letter or an underscore, never a number or a special character. No special characters allowed in the variable name itself, but numbers are allowed as long as they're not at the very beginning of the name. So since I say 5 values, I'm just going to put 5 there, and remember that for later. Now we're going to have 5 different user inputs. So I'll just say UI1, UI2, UI3, UI4, UI5, and then I'll just make one that's called UI, where maybe I can use it as a temporary holding variable to later put into UI1, UI2, UI3, 4, 5. You'll see when that design comes into play. So since we're going to be doing the average, I'm just going to make these floats so we can get a more precise answer. And then looks like we're going to compute the sum, the average. I'll just use AVG for average, and the product, I'll use prod. I can define or initialize these variables first by just giving it the equal to 0, where the equal sign is the assignment operator. And then the average and product, that can be calculated, so it doesn't need to be initialized. But some should be initialized unless, because when you're adding these numbers together, you're starting out at 0. So if you don't initialize it, you'd have to then set sum to whatever UI1 is or UI2 is, and then add the rest after that. So the first thing I want to do is, now that we've got everything set up there, is to actually prompt the user and store their input. So I'm going to start out basic first, right? So I'm going to start with my prompt. Please enter in a number value, and I'm going to remind myself it's float, or remind the user that it's float, and we're going to take that and store it into my temporary user input variable. Remember, you need the ampersand when using the scanf, and I'll store it there. Now, why did I do that? Well, I don't know if it's valid input yet, right? So now we need to check to see if it's valid. So what can we use to check to see if something is valid? Well, when you want to run a certain block of code based off of a condition, that sounds like an if-else type control structure. So in this case, if UI, as long as, let's say, what we need to define valid input. What's valid input? Let's just say valid input is greater than 0, but less than and less than 100. Yeah. No. Let's do less than 101. No, let's just do less than or equal to 100. Sorry. Okay. So if the UI, maybe you want to check for invalid versus valid, but that just depends on how we want to have this looped over and over again, right? So let's think about that before we actually build that. So if we're going to loop this over and over again, I'm going to just give a standard while one here so we can kind of picture how this is going to work. Alright, so this is going to loop over and over and over again until they give me something that's valid. So we can stop a while loop by using what's called a break statement, right? So if the UI that they enter is valid, then break the while loop. Okay, so if it's greater than 0 and UI is also less than or equal to 100, then we can break this loop. Okay. So how do we know then which UI to put this into? Is it 1, 2, 3, 4, or 5? Well, we know we need to repeat this code 5 times, right? Because we're going to ask them 5 times to enter in a number. So when we know the count of something, we can use a for loop. So I'm going to make a counter. Actually, yeah, I'm going to make a counter. I'll call it I in this case. And we're going to encompass this whole while loop into another code block. And then we're going to use the for loop, right? So in the for loop, you've got 3 different things separated by semicolons. So in the first one, you initialize your counter to whatever you want it to start with. I'm going to say 0. And in the middle, you tell it to keep running that for loop as long as this middle portion is true. So as long as I is less than the number of inputs, which was defined up here, as long as we haven't reached our number of inputs, then run the for loop. And then at the end of each for loop, add 1 to the value of I, which is what the last portion does right here. So I'm going to save that. Okay, so now, once again, how do we know which one to store this on? Well, since there are 5 of these, and this for loop is running 5 times, well, we can use something like a switch statement. Okay, so the way the switch statement works is you've got the keyword switch, and then you've got something in parentheses that we're trying to check the possible values of. So, well, I holds pertinent information. And so how these cases work is these are the possible values of I in general. So we're going to say I starts at 0, so 0 is a possible case. Put in a break for that case. I can be 1, break. I can be 2, break. I can be 3, break. I can be 4, break. Can I be 5? if I is less than 5, then don't run it. So it won't work. Or case 5 is not one of the cases. Okay, so what's happening in each side of these, on the inside of each of these cases? Well, we've got the user input, valid user input if we make it out of this while loop. UI is valid. So now, on the first case, let's just take what's in UI and store it into UI1. Okay? I'm going to copy that. On the case 1, we'll put it into UI2. On case 2, we'll put it into UI3. On case 3, we'll put it into 4. And then finally, case 4, we'll put it into UI5. So UI gets checked up here, right? And then gets put in only when it's valid. Okay. Alright, so let's just do a sanity check right after the for loop. Printf. We'll just print out the numbers. I'm sorry, these are floats. %f. So that's the first, second, third, fourth, fifth. We'll add an extra new line there at the end. And then for each placeholder, you need a variable. 3, UI4, UI5. Save, run that. Okay, so please enter in a number value. So I'll just do it this way, so hopefully it's easy for us to read. And sure enough, we've got everything that's good. So now, let's try and enter in something bad in the middle. So do this over and over and over again to show that it's bad, right? And then 3.3, 4.4, 5.5, and see only the valid stuff shows up. Fantastic. Okay, so now we need the menu portion. We asked them to enter in the 5 numbers. Now we would like to ask them to enter in, to choose something off the menu. So first let's create the menu with the printf. So for your number 1 thing, I'm going to use the tab. Actually, I'll put menu, new line, and then we'll do tab 1 space. Then I made it the sum average product exit. So sum, and then I can do new line and tab it to sum average, and then I can copy this, change this to 3, oops, make that product, and finally 0 will be exit. Whoops, 0 exit. And then at the bottom, we could say, please choose from the above menu. Do that. All right, let's just see how that looks. Okay, so menu, tabbed over, 1, 2, 3, okay. That's pretty good. So now scanf _ s, since we're using a UI, so UI is there. Let's make another one. Let's do menu UI. So I declared a new variable called menu UI, made it an int, since it matches our what we're expecting, a whole number 1, 2, 3, or 0. We can do that. So ampersand menu UI. We'll store the value in there. Now, instead of using a switch, since I use a switch up here, I'll use an if-else-if type style here. So if we get into, okay, we're going to select something off the menu, right? So if menu UI is equal to a 1, else if menu UI is equal to 2, oops. Else if menu UI is equal to 3, and else if menu UI is equal to 0, and then else. So on this else, they've entered in a value that's not applicable to the menu, right? So I'm gonna just say printf, please enter in the possible values 0 through 3. Double new line there. Okay, so what does that mean? Well, we basically have a check here already, so we don't have to check for valid input because this else kind of handles it. So since we have the 5 inputs already, let's put this in its own while loop, the menu. So we could just keep printing out the different possible values based off of what the menu is doing. So for the sum, we had, it's under 1. So sum is set to UI1 plus UI2 plus UI3 plus UI4 plus UI5. Okay, so we can do it that way. Printf, the sum is, and then do it this way, %f, new line, and for the placeholder we put in sum, and then 2 is the average. The average is the, now I could take this whole thing, right, put it in here and put divided by number of inputs. I can do it like that, or I can do it with sum, but if I use sum, that means I can't put it in here, right? Because if it gets into here, if it does not get into here, but they choose 2, and it only gets into here, that meant it couldn't get into this block of code and actually compute the sum. So that means I need to move this on the outside and compute it immediately. Okay? So if I compute it beforehand, I can use it across any of these that may need it, in which case the average does need the sum, and I just divide it that way. So you can actually pre-compute the average out here as well, and just do it this way, and then just put AVG in here. Perfectly fine. And then so printf is, see, the third one's the product. So the product is %f, new line, and I could just take all of these and replace the plus sign with multiplication. Alright, do it that way. And then if I want to keep these to 3 decimal precision afterward, I can just give it the 0.3 in between the % sign. And if they put in 0, that means they want to exit. You can say goodbye, and is that one word? We'll make it one word today if it's not already. And so we need to break the while loop at that point, and then we can just break right there. And then here we can use what continue to jump back to the beginning of the while loop, but since it's at the end of the while loop and we don't do anything after that, it's kind of pointless, but I just thought I'd throw it into the video just to remind you of it. So let's give it a try. 1.1, 2.2, 3.3, whoops, 4. Okay, so it just repeated 3.3 twice. See what the sum of that is, 14.3. Let's check it out. 1.1 plus 2.2 plus 3.3 plus 3.3 plus 4.4. 14.3, great. Let's do the product real quick. 1.1 times 2.2 times 3.3 times 3.3 times 4.4, 115.957. Okay, cool. So that worked out. And then let's do the average. So 14.3 divided by 5, 2.86. And there it is, 2.86. We hit, let's say 5. Please enter in the possible value 0 through 3. Great. Hit 0. Goodbye. That's the end of the program. Okay, let's see. Alright, looks like I fit in everything here. So just to fit in an OR logical operator, we can do this. Okay, let's say let's generate an if check here using an OR logical operator, checking for invalid input. So what's invalid here? Anything that's less than 0 or greater than 3, right? So if the menu UI is less than 0 or the menu UI is greater than 3, then we can tell them to enter in the proper value, and then we can continue the code. So this is where it would be useful. You check here right away, and if it gets into this block of code, that means it's not valid. So you want to start over, print out the menu, and ask them to enter in a new value. And the rest of this, you're not running this code every single time uselessly with bad numbers, right? Because if the way we had it before, they could enter in bad numbers, it would compute something, and then it would just start over again, right? So now we can save computational time and resources by not having to execute this information every single time. So that should be it. There will be a Q&A session on Monday. Gather your questions while you can, right?